Hello and welcome back to the last part, that is the writing part 3 in the grade 9 elite end of term explanation videos. I am Justin D'Souza, your math teacher. This is my channel Best Math. And now we will begin with the writing part. Only 3 questions are there. Before we begin, kindly ask you, if you're not yet subscribed to my channel, please do subscribe to it. Now you might be wondering, always I ask you to subscribe. Now, the reason why I say that is the stats are amazing that 80% of the people who watch my videos are not yet subscribed. Only 20% are subscribed. This was like a couple of days ago. But I'm very grateful for all those who are subscribed. But I'm very grateful for all those who watch my videos. Just do benefit from it. It's free. You can just watch, learn, and do well in your exams. That's the most important thing. But subscribing is free. So if you don't mind, please do hit the subscribe button. Thank you, guys. Now, and those who all subscribed and those who share the videos, I am grateful to you. Thank you so much. Now, then we will go to the first topic, the 21st topic in the writing. It's about different situations on probability and mutually exclusive, non-exclusive. There are 5 questions. There's 6 questions. Now, here we have a situation where you roll 3 dice. What is the probability that the outcome of at least 2 of the dice will be less than or equal to 4? Explain your reasoning. First of all, how many dice are there? 3. We know if it was 2 dice, it would be 6 times 6, total possibility 36. But since here it is 3, 6 times 6 times 6, or 6 cube. It is uh, 216, I guess. 6 cube is. Okay, 6 to the power 3. Let me just double check. Okay, yeah, 216. Okay. So, yeah, it's 216. Now, what you need, what exactly is required? It is that 2 of the dice will be less, at least, sorry, this is very important. At least 2 dice will be less than or equal to 4. That means probability of at least, okay, at least 2 dice, 2 dice, 2D will be less than or equal to 4. What does it require? What does it mean? Sorry. At least 2 dice will be less than or equal to 4 means it can be any. There are 3 dice, right? One, two, three. So either first and the second dice will be less than or equal to 4, or first and third, or second and third, or all the 3 also can be less than or equal to 4, isn't it? So let's write that. Probability of all dice less than or equal to 4. Okay, it's less than or equal to 4. Then plus probability of what? First and second. Let me write 1 and 2. Then we have plus probability of 1 and 3. And then what is there? Last one, plus probability of 2 and 3. So I hope this is clear. What I have done is I'm directly solving this. You can directly write this in the answer, but write it in a better way. We will see it. I think so. It's there. Yeah, it's there over here. We will see it in a while. For now, let me just write it. So now, what does this all dice mean? All dice means all the 3 will be less than or equal to 4. What does it mean to be less than or equal to 4? The possibilities are 1, 2, 3, and 4. That is 4 out of 6. That is for 1 dice multiplied with the second dice, same thing, and the third dice, same thing. 4 by 6 into 4 by 6 into 4 by 6. Plus, what does it mean to have probability of 1 and 2 dice equal to less than or equal to 4? That means first die will have probability 4 by 6 multiplied with second die also will be having 4 by 6. Now, what about the third die? It won't be within less than or equal to 3. So the other two, what are the other two options? 5 and 6, isn't it? So it is 2 by 6 over here. Now, same thing over here, but the first die will be 4 by 6, second die will be 2 by 6, and the third die will be 4 by 6. And last one over here will be the first die. Let me just change this position. Last one, 2 and 3 will be 4 by 6, whereas this one will be 2 by 6 multiplied by 4 by 6 and 4 by 6. And that is the answer. I mean, this is basically the answer, but don't directly write it. It's a writing question. So let's solve it. 4 times 4 is 16. 16 times 4 is 64. 64, and we know 3 cube is 216. Plus, what is this? 4 times 4 is 16 times 2 is 32. 32 by 216. Now, all the others are the same thing because it's 4 times 2 into 4. It's the same thing. 32 by 216. And lastly, we have plus 32 by 216. Now then, after this much, just put it in the calculator and you'll get the answer. Let's do it. 64, 216 plus, I'll just write 3 into, okay, because 3 times, I'm just lazy to add it 3 times. That's being honest. Okay, so the answer is 20 by 27, that is 74.07 or 0.74%, 74%. Oh, wait, what happened? Let us see. 64. Now, it's not given exactly why it is 64 by 216. I think so. It's there. Okay, over here it's explained, I guess. So you can just go through that. But over here you can see 4 by 6 multiplied by 4 by 6 multiplied by 4 by 6 is 64 for all three dies. Whereas for first and second dies only, it will be 4 by 2, the 4 by 6, 4 by 6. Here, remember, it will not be less than or equal to 6. So it will be remaining 2 by 6. And similarly, you can solve this. So that is the answer, 20 by 27 or 0. The same answer we also got. Okay. Now here, find the error. Theo and Mason wants to determine the probability that a red marble will be chosen out of a bag of 4 red, 7 blue, 5 green and 2 purple marbles. Is either of them correct? Let's see. 4 red marbles. Okay, favorable outcome is 4. Total is 4 plus 7 is 11. 11 plus 5, 16. 17, 18. Wait, let me. 11, 16, 18. Okay, yeah, this guy is wrong. I got confused. Okay, 18. Then, this is the answer, right? What did this guy do? Theo is wrong. 4 by 17 he did. And here he has done not for I mean, this is the probability of picking the red marble, isn't it? He has not picking red marble. 1 minus means not that, right? So he has done that one. But the answer is 4 by 18. Okay, there are 18. So this is the answer, probability of picking red marble. But he has done over here 1 minus, that is choosing, that is not a red marble. Okay, basically that is what he has done. Yeah, choosing a quadrilateral, that is a square, and quadrilateral, that is a rectangle. Look, this is not mutually exclusive because they are all interrelated. Square is a quadrilateral, rectangle is a quadrilateral. Now, they are basically, whether it's mutually exclusive, no, they are not mutually exclusive events. Choosing a triangle of equilateral and again, equilateral means equiangular, right? If all the sides are equal, the angles are also definitely equal. So basically, it is not mutually exclusive. This cannot be. Choosing a complex number and choosing a natural number. Now, a complex number means what? Now, imagine I have 2 only. This is a natural number, right? But it can be written as plus 0i. Each number is complex number as well, isn't it? So this is the thing. They are not mutually exclusive events. Okay? So, because they mutually exclusive means they have no relation among these both. Okay, now say for example a deck of cards, this is the best example. 52 cards are there. I will choose a red card or a queen. Okay, red card or a queen. Is this mutually exclusive or not mutually exclusive? It is not mutually exclusive because there is a red queen as well, so it overlaps. So this overlaps. There is a red queen, that is either queen of heart or queen of diamond. So it is not mutually exclusive. But same deck of cards, I am either picking a 2 or a 3. This is mutually exclusive because 2 is only 4 twos. 3, I can't have a common number between 2 and 3. So they are mutually exclusive. So that is what it means. Over here, it is not mutually exclusive. And last one over here, explain why the sum of the probabilities of 2 mutually exclusive events are not always 1. Here, when 2 events are mutually exclusive, it means that they both can't have both. They can't both happen. Okay, sorry for that. But it does not mean that one or the other events must happen. The sum of all possible outcomes in the sample space must be one. Obviously, the sample space of all possibility will be one. This is about mutual events. Two events are mutually exclusive. It means that they can't happen. They both can't happen. Okay, I'll just tell you what exactly. Just now I told, right? What is mutually exclusive? The same thing. You can write that. Now imagine picking a 2 and a 3. These are mutually exclusive because both can't happen together. Whereas if you're picking a red card and a 3, yes, this can overlap, right? Both can happen. That is, heartens and diamonds of 3 and hearten of 3 are mutually are inclusive. Both are equal, right? Common, sorry. So it cannot be mutually exclusive. This is the difference. So that's the end of this topic. Basically, a simple topic about probability again. Please make sure you go through problems. Just be sure, read the question properly and then try to solve the problems.